Alright, let's see, you guys finished? You should have finished. Yeah, so it looks like... Alright, good. Alright, so today we're gonna continue talking about Java. We're gonna do more stuff with our programs. Last time, our program looked like this. And I think we had system, that out, that, and we had some things there. Close this, close this. So that's what you did last time, right? And you were supposed to bring out flash drive, or if you have Google Drive, who cares, whatever. But you need to save your program so you can use them in the next class. So, a couple things I gotta show you today. First, remember we talked about the lids, what they look like. So we said to start a method, or a block, I should say, we start with the curly brackets and then we close with the curly brackets. And this curly brackets belongs to this line that says public class, my class. So this one matches this one and this one matches that one. So if you have a bunch of them, it's kinda hard to figure out which one belongs to what. So it'll be nice if you put a comment there, or a line, or a tag, or something. So to put comments, you can use, a working marker. You use 2 forward slashes. And then whatever is after the 2 forward slashes is free text. It's called comments. And when the compiler reads your code, this is not code. This is just comments that are ignored during compile time. So I can say here in main maybe. And here I can say in class, whatever you want to write there. We also said that we can start talking a bit about variables. And we said methods and variables kind of look similar, but the method had parentheses to indicate that's a method. And inside the parentheses, they might have what we call, what's inside the parentheses? Remember? Arguments or parameters. So they might be none, but still a method will have parentheses, right? So we know this is a method called main. This is the point of entry, and has some set of parameters that we're not using yet. We're going to talk about those maybe around the midterm. What's all this? And we use this method called printline. But this method printline actually resides inside this library called system, and the sub-library or class called outstream. So this stream, outstream, is what goes into your monitor. So whatever you use, system.out is prints in the on the command prompt of your monitor, right? So far so good. Easy stuff, right? So this is the out stream. You know, like you're streaming videos and stuff. So how do we ask stuff back? You know, we can write all the programs that just display stuff, but really you want interaction, right? It's like you're writing a game where there's no input from the user, so it's just becomes like a movie instead of a video game. So when I was a kid, my brother, I had to babysit my brother, so I would just record like Mario Bros or whatever, play it, finish it, and then say, oh, here, you can play, so it wouldn't bother me. And actually he was watching the movie of me playing. It's like, why turn left, you turn right, why? Always trying to help you, don't worry. It works as a babysitter. Anyway, so now we need to figure out a way to get stuff in. So it will be something like system.in, basically. However, when you talk about user interaction, you have to have, we call it pointer. So we gotta point to the keyboard so you can read from the keyboard. You know, streaming is basically just a flow of bytes coming in, and they never stop. So you're always listening for stuff coming in. So when you do stuff to the monitor, you just printing out, you can just do it by system.out and then whatever you need. Well, however, to read from the keyboard, the computer needs to know, has to be listening to the keyboard. And always be listening to know when you're typing or you're done typing or whatever. When you're sending out stuff to the monitor, just sends it out and the computer forgets about it. It's done, sent to the monitor, who cares? So, let me erase this for a second. And you can open your Eclipse or NetBeans, whatever you want to use. So, in order to be listening to stuff, we gotta scan basically the keyboard. And remember how we declare variables? We kind of talked about that last time. First thing you do is you gotta say what type of variable it's gonna be, and then you give it a name, whatever you want to name it. So there's a variable type called scanner. And this thing called scanner, is this a primitive type or an object? What do you think it is? Remember we talked about those things? Primitive, there were like a handful of them. We call, well, there are 8, but we mentioned 5. We call it int, long, bool, double, and there was another one that wasn't primitive. What did we call that? Remember? Object. So, do you think a scanner will be a primitive or an object? It's an object. So anything that is not primitive is an object. And an object, we're going to talk about that, has some methods available that correspond to or relate to that object. For instance, we could have an object called payroll, and there's a method that says pay employee, something like that. If you have a primitive type, let's say integer, does the number by itself do anything? No. If you want to figure out the square root of a number, then you can use this class called math, and then you can use the math square root function. Because I don't remember how to do it. I did it one time in 8th grade and that was it. Alright, so this scanner class or object, we use first the type and then we give it a name, whatever you want to call it. I'm going to call it keyboard or KB or whatever you want to call it. And do you remember last class I mentioned how much memory each thing uses? We say, hey, integer uses 32-bit, the boolean uses 1 bit, a character uses 8-bit. How many bits do the objects use?
64.
Yeah, in this particular is 64, which is 64-bit operating system. And that 64-bit, what do we call that? It's a word size, right? The word size is 64-bit. No, word. The word is word. So this is basically holding an address, right? So where's this address going to? It's like you have an envelope you want to mail, but it doesn't have an address yet. Where's it gonna go? Nowhere. It needs to find an address where a scanner exists. It's like you gotta know what the address of this thing is. Well, you think if you turn on your computer, there will be a scanner loaded in memory? No. So like, you have all these programs installed in your computer, but because your computer is turned on doesn't mean Excel is running automatically, Word is running automatically. No, you have to start them, right? So, in order to start them, basically they load into memory, right? Read from the hard drive and then loads into memory, and then they start executing all these instructions. To do that, so remember what we call the equal sign? We call it the assignment operator. And I'm going to show you a few keywords here. I'm going to explain what each one means. So, I think I'm going to run out of space here. I'm going to move this down just a bit. All right, so what does this new thing mean? This keyword new, its job is to allocate memory. So this how much memory is it supposed to allocate? Well, whatever is followed by. So if I said to you, when you declare a variable that is a type object, you only allocate 64 bits. Right? Well, how much memory do I need to represent a car and all the attributes of a car and all the things a car can do? I don't know, it's more than 64 bits. Right? So what this thing does is allocates memory and then figures out how big a scanner is in memory, and it's gonna try to find a contiguous amount of memory that fits this size. Does it make sense? So you have RAM. This is your memory chip, and we put these imaginary lines to indicate chunks of addresses. And to make it easier on us to indicate these are memory addresses, we usually label them with a 0x in front. And then we're gonna do a decimal representation of the addresses. The computer is gonna do in hexadecimal. So let's see, we start an address 1000. And then we start, the next address will be 1064, right? The next one will be 1128, and then so to 9, and then and it keeps going up, right? So basically, these are bit numbers. In reality, the RAM starts at bit 0 and then goes all the way to whatever size your chip is. And this is just one big gigantic memory RAM. And then the operating system is going to section chunks of bits for each program. So the program uses it has its own memory space, we call it. So what the computer does, let me erase this. The computer reads top to bottom, right? And then right to left from the equal sign. So the computer goes here, this line of code that says declare object type scanner, and we're going to call that keyboard. So the computer knows it needs to allocate 64 bits. Right? So it's going to say, okay, scanner keyboard is going to be here. This address, it doesn't put the name of it, but we're going to put the name just to, you can read that. So keyboard is here. So what the computer actually is going to do when it runs, it's going to replace the name keyboard. It's going to get rid of that name, and it's going to use the address it allocated. So this is address 1000 for the keyboard. What do you think the content of this address is? What do you think is in here? You don't know, right? It's just maybe junk. It's a bunch of zeros and ones, right? I mean, there's voltage there, and maybe this address was used by, I don't know, by Angry Birds before you closed it, and then you open this program. That's being reutilized. So, but when you declare an object, Java is going to allocate it. It's going to put a bunch of zeros. So this address is pointing to a bunch of zeros. Remember what we call that bunch of zeros when we talk about an object? I gave you a keyword last time.
False.
No. Well, yes, that if it's a Boolean, but if it's an object, what is it? Yeah, it's a null. So right now we call it null. Null pointer, or null address. So if this is pointing nowhere, it's just null pointer. So like an envelope without destination address. Alright, so that semicolon, so the end of the instruction, and now allocated this address here. So right now, this address 1000 is actually our keyword. Right? So what's going to do every time he sees that address 1000, and the word keyword is replaced by the address 1000, right? Or whatever address happens to allocate. And then he sees an equal sign, right? So what's going to do is execute whatever's on the right side of the equal sign first. However many CPU cycles take. So it says new. Well, new allocates memory. How much memory? Whatever the scanner is. So what's going to do? It's going to grab this scanner. It's going to grab this blueprint of a scanner. Alright. It's going to say, okay, here's the scanner. I'm going to build one. And it's going to build it in memory. It's going to use a finite amount of space. And I don't know how big it is, but let's say it's this big. Maybe I should use another color. So let's say use this. So I use this chunk of memory. That's what the scanner used. All objects are the different sizes. The key is that whatever object it is, it's in a contiguous amount of space. So it finds a hole that fits the scanner and it grabs that chunk of memory. And that's what this new does. This scanner class, it looks like a method, right? If you notice, it has parentheses. It's like a method, right? But actually, scanner is a type. So this and this they're the same. So when you have this keyword new allocates memory, right? It's followed by a class name, let's say, or a type scanner. And you see these parentheses, this whole thing, it's called a constructor. So what does this constructor do? Well, the job of the constructor is grab this chunk of memory. And the constructor is like a method. The only difference is that method is the same name as the variable type, the same object type would be the correct word. You follow me? Right now it might be too much concepts, but once you get to do them over and over, it'll become second nature. So, and here, inside the parameter I pass is my in and the system that in stream is my keyword. How many keywords do you have? Not one. Technically, yes, you could have two, I think. I mean, you can have two mice. I do on my laptop, right? The board here and the little thing in the middle, and I can still plug in a USB mouse and it still works. Yeah.
So what does the constructor do? I don't understand.
The constructor does is allocates this memory. And you don't need to know the size of it. It's done by the computer. I mean, you could, I mean, if you need to know the size, yeah, you can find out what exactly the size is. But all it does is creates this scanner for you. So I build a house, I grab a blueprint, right? And I go and follow the instructions of this blueprint. Just because I have a blueprint doesn't mean I have a house built. No. And do I go build a house first, figure it out, and then come back with the blueprint? No, right? At least you shouldn't. I did that with my solar panels. I didn't know how to do them, so I bought a bunch of eBay, bought the racks, mounted in the roof, figure out where to put them, and then I make the drawing. I went to the city. Here, I want to put the solar panels. Actually, I already did. But you're not supposed to do it that way. Then I got a letter from the SDG and ESG yelling at me for turning them on before the permit was submitted. But I mean, it's so hot. I mean, the AC is going off all day long. Anyways, so this constructor allocates, goes build this house, builds this scanner, and it built it here. And where he built it? Oh, at the address 1192. That's where it begins, right? So like when you punch the address in Google Maps or whatever, it gives you the coordinates of the front door. It doesn't give you the coordinates of the living room or, right? It just gives you the entrance. So the entrance address is 1192. So the computer sees an equal sign and goes to do everything that's on the right side. So this whole thing, new scanner, calls the constructor, builds the scanner, comes up with the final result is the address where it built it. Right? So it just comes with 64-bit number. It's the address. So then sees the equal sign. And it says, oh, I have an address or a variable to hold this address I just came up with. So now this one doesn't have a null pointer. This one now will have the address where it actually allocated the memory or allocated the or created the scanner of it. Make sense? So throughout the years, like I never got rid of all my paid stubs and all my bills and all my taxes, and I have them in those filing boxes that, So, yeah, I should now scan them all, right, and get rid of all those boxes, but if I want to go back to one of those, I don't go look for all the boxes that I have stored. I go for the one that says taxes, right? I just pull them out. So, it's like this. This one, this keyboard, or this address 1000, is pointing where all my stuff is. Makes any sense? Maybe that was a bad analogy. But, so, if I need my taxes, I don't go grab the bill for all my, I don't know, my credit cards or whatever, right? I just grab the box that says taxes. And then I look for the one I need. If I go to this storage unit and grab all the boxes and put it in my living room, it's too much, right? I just grab the one I need. So if you open Eclipse right now and type this, you're gonna get an error. It's gonna say, I don't know where the scanner is. Which box is the scanner at? Or you gotta go bring that box from the storage unit and find it there. Okay, so how do I bring that box in? We call it a library. Where is this library at? Or this class is in a certain library, you gotta bring that library in. So to bring a library into the program, I'm gonna use this keyboard. And what this keyboard does is import. This keyword import brings that box, and it needs to know which box do you want. And though I know the scanner class is in the java.utilities library. So there's a big box or a storage unit that has all this Java stuff. But I don't want to bring the whole storage unit, I just want the box that has the scanner. Okay, then that's in the utilities box. And you want to bring the whole box, or you just need the scanner? Well, I just need the scanner actually. Okay, so import this like this. And now, you won't get that error. If I didn't do this import, instead of typing scanner, I will have to type the whole thing, java.util.scanner, everywhere. So Java knows where to find the blueprint of that class. So far so good? All right. So, I'm going to declare another variable here, which should have been at the beginning, but I ran out of room. I'm not going to rewrite the whole thing here. So this is a primitive type. And I'm going to call this your age. Or something, whatever you're going to call it. So the computer finished this and see this other int. And it says, well, how big is an int? It's 32-bit. But I have a 64-bit operating system. So it's going to allocate memory for an int. Let me here. Let's call it your age here. But it's just going to use half of it. because it's only using 32 bits. The other 32 are pretty much wasted. There's a way not to waste it, and I'll show you. I'll show you later how to. So what the computer is going to do is going to replace this, right, with the address. 1064. And then I want to ask the user how old you are. How does the user going to know they're being asked? You got to display a message on the screen or something, right? So how do we display stuff in the screen? We use the system.out, right? And I'm gonna say so remember when we first did the hello world, we just displayed the message hello world, right? Does the computer know it's supposed to expect something from the user? When you print it out, hello world, does the computer expect something from the user? No, you're just displaying a message, right? Is there any difference here? The computer doesn't speak English. The computer is just displaying a message. Right? This is for the user. The computer doesn't know that it's expecting something. So how do I get stuff back? Well, I want to get the user's input and store it in this variable. Right? So what I'm going to do, I'm going to read from the keyword. Okay, I got the keyword, and when I read from the user. So this keyword is an object, right? I didn't, just because you name it, I could have named the scanner your age. The computer wouldn't know it's supposed to be an integer. This is for you. The computer only sees addresses, right? So when it's when it's an object, like scanner is an object, I can do this, put this dot after the variable name. Remember, we call this the dot notation. And then a list of all available methods show up. There's a method called next integer. Next int, actually. And this method, next int, is a method because it has parentheses, right? But there's nothing in the parentheses because it doesn't need anything. So this method, next int, what it's going to do is read numbers from the keyboard until the user hits enter. And that number, I mean, the computer doesn't know you start typing 4, 5, oh, that was 4, go back a space, it was supposed to put 4, 9, or whatever. It doesn't read until you hit enter. And remember, the numbers are actually read as text. We saw the ASCII values. So once you hit enter, this whole method is executed somewhere in memory here. Somewhere here, there's a method called nextInt. Somewhere there. And you don't need to know where it is exactly. All you have to do is go to the keyword. Oh, the keyword is here. Let's point it to the address here. Here's the big chunk of memory address. Now I need to get to the next int. So you press that next int, it's going to go to the next int memory address. It's going to execute that. Comes up with the number. And then it comes back with the number 12, let's say. And then sees the equal sign. Until then, it sees the equal sign again. And it says, oh, I gotta store that value here. Now I have it in memory. And it's up to you what you're gonna do with it once it's in memory. You display it back, you do some calculations, whatever you wanna do. So for now, we're just gonna print it back out. And I'm gonna say this. So, notice this one says print and this one says print line. The only difference is at the end it puts the carriage return new line. So, this is a number. And here I'm using the plus signs to add a number to a letter, to text. I can't do that. So when the computer sees this, assumes this is going to be converted into text, and then he adds text to text and just put them together. And the word is on the names, the strings basically.
What's that
What?
word? What's the word?
Concatenate.
What's that mean?
This is when it's free text or just text, we call it a string. When you put two strings together, concatenate the strings. It's basically attach. That's what it means. I think it's Latin, and it's like chain, when you put chain links. So, try this in Eclipse. Yes.
So you get the character from the memory, and then it stores it in your age and the address. Like, is that how it?
Yeah. So the RAM is just storage space, and your age is a variable I declare type int, and this is the address, right? So what the computer is gonna see, you type here, whatever, 24, comes back with the number 24, and it doesn't see your age. It says that, right? And it says store the value or the binary 24 in this address. So it just puts that number 24 here. Any other questions? I'm thirsty, so I need coffee. So let's take 10 minutes. All right. So a couple of things. If you notice between the word R and the double quotes, there's a space. Otherwise, when it prints out, it's going to be all jammed together. And you get this yellow squiggly line under the keyword scanner. And it says it's never closed. So, scanner, this class scanner is reading an input stream. And once it's created, it doesn't change where it's reading from, and it's always reading. So, your selected here when you create it, you type something in here and you use system.in. That means read from the keyboard. And you keep constantly reading from the keyboard. But it could have not just been from a keyboard. It could have been from a file. It's streaming from a hard drive. It could have been streaming from a network card, from a serial port. So, if you're reading from a file, you open a file to read it. And let's say you're at work and you open this Excel file, or somebody, one of your coworkers, open this Excel file, you want to open it, but that person has it open. And you want to modify it, and you can't, because why? That person has it open. So what do? You call that person and say, can you close that file for me? So you can modify it. Same thing here. The computer doesn't know, once it starts the scanner, it doesn't know it's reading from the keyboard, but it doesn't know once it's created that it's okay to be open. I mean, you don't disconnect the keyboard when you're done, right? So it's giving you a warning saying you never close. If you want to get rid of that warning, you can type keyboard .close at the end, and that warning goes away. So what happens is the computer reads top to bottom, right? Start reading here, 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 here. When it hits there, if it doesn't exist, it sees this curly bracket, right? Before I had this sentence here, what happens is anything that existed here, the computer created or declared this variable, and then allocated memory for that object. Then you declare this other object here. So the RAM looked like this, right? But then the computer does whatever, and then it reaches the end of your method. And pay attention to this because you're going to ask me later. So what happens when it reaches the end? What happens to all this? Does it stay there? Or does it go away? What do you think? So when it reaches the end, when it finds this curly bracket, or any curly bracket, when it finds the curly bracket, the closing curly bracket of where you declare variables or you allocated memory, all that memory is given back to the operating system to be reutilized for other programs. Otherwise, you will run out of memory. So at this point, when this curly bracket ends, closes, this is reached, all these things are read. They're given back to the operating system. In other words, you release those memory addresses. Java does it for you. What will happen if it doesn't release them back? And then you call another program. That memory is wasted, right? And it's not accessible because the program closed here. It has a name in computer science. You know what that's called? It's called memory leaks. A memory leak is an address or a section on the RAM that is not accessible anymore because it's blocked. That means it got utilized and it didn't get released back to the operating system. So once the system.out print line is this line is executed, the next line is it's the end, basically, right? It closes. So anything that was here is released back to the operating system. Guess what happens to the keyboard? It's released back. So it doesn't really matter if you closed it or not, because automatically it's just erased. So that's why it's giving you a warning If you want the warning to go away, you can do keyboard close. And so when we create or allocated memory, we call this a constructor, right? What do you think is called when it's released back, the memory is released back to the operating system? What do you think the name is? It's destructor. You don't execute, you don't write code for the destructor. But one of the things it does is close any open connections it has. So you get this yellow squiggly line, it's a warning that you didn't close it, but it's okay. If it's the keyboard. If it's a file or if it's, then you gotta close it. Alright, so any other questions? Yeah.
My scanner said, oh, we're talking about this or this?
Same thing.
Same thing. Okay. Well, my scanner says this cannot be resolved to a time.
Yeah, that means you don't have the, where is the scanner at? It's in this library. You need to import.
Oh.